Okay, get back into it. Last time we were writing this JSON parser, right? To do skip white space function needed. So let's write this skip white space function. Uh, White space. What kind of white spaces would be there? Is slash R a white space? I don't know. Okay, let's think about that when we need to. So should we put the white space function inside the JSON parser? I think so, because no one else is going to use it, right? I mean, we could put it in support, I guess. I think I'm overthinking this. Let's just add this. Skip this. What the skip white space function is supposed to do is check if start JSON file, the JSON string, it's equal to what is it supposed to be equal to? It's supposed to be equal to slash n white space, yes, or star JSON string equal dash d. Let's do this. Y. Let's hope I copy that right. I think I messed up. Y f oh, y def. Okay, and d, right. And let's have this. What else is there? Slash d slash r, the action space character. Oh, what else could it be? Okay, that's fine for now. I guess slash r. Mhm. Okay, if it's equal to any of these things, we just got a JSON string skip, or we had to assert not equal, not equal to no. Instead of if, it should be while. What else? I think we wrote something that is wrong. Not JSON string. So when is the pointer itself null or D? It won't be null, right? It should be this. Similarly, we had another position where, yeah, I think this should be fine. Okay. Yeah, looks good for now. Then let's write pass number. Oh, I forgot to add the skip white space. So we start with skip white space. Then we do the same. What did you do? Where else we add this? We skip the white space, we consume the character. We don't skip any white space over here, right? And after this, skip, wait. I think it just needs to start by skipping white space until it gets to that character. Yeah, I think that looks fine. So let's start the pass number one. Same thing. White space, right? If the JSON string, could I check if the JSON string is digit? Do I have to typecast it to int? Mhm. I could typecast it to int and then check if the ASCII value is in between those. Is that what ASCII value is? Uh, hmm, Let me just check if this is digit or something like that. Oh, there is. Int C is digit. But may recognize additional characters. Why is it int C? They had to typecast a character. Test for a decimal digit character. The char get automatically typecast to int. Okay, I think we can just try this. No harm in trying it, right? If if this works, then that's one less headache of typing stuff. I mean, I could write it down by myself, convert it, or do some shit. But is it really worth the fucking hassle? I'll include the type package. if the JSON string is digit. Yep. Okay. If it's not is digit, oh, what do we do with this? Printf the JSON string as invalid number passing JSON. We probably have a check later on while like before this function called to send it to this function. So I guess this is a redundant check. We could probably remove it, but yeah, we can figure that out later. Uh, we don't consume it because we start the is digit thing, right? And the same shit while is digit is on string. Uh, while is digit JSON string. Like while it's a digit, we do JSON string plus plus. Of course, we have to uh, star dot equal to JSON string. And same checks. I think I can just call it piece of shit. One copy. I think that should be fine. And we obviously have to change the bounce check thing because JSON string would be at whatever is after the digit, the character after the digit, right? Mhm. So the character after the digit. Let's say the digit is 1234. Okay. JSON is like assume there's like a blank space or something. JSON is at the blank space, which is at 115, 10, 11, 12, 13, 14. JSON is at 14. 14 minus 10, 4. So yeah, should be fine. Plus one further this thing. This is fine. This is fine. This arena lock. Pass the arena. I think I have to change this in the function def also. We add the zero at the end. Now here's a tricky bit. We don't red store here. Instead of red store, we have to now convert this red store. Oh, I think it's A to IO. A to I. Convert a ASCII string into an integer. I don't know if this considers Unicode characters or not. I think it doesn't. Conforms to IEEE standard 1990 POSIX 1. I think that didn't have Unicode. So let's just make a note of that in case. But for now, we can just use A to I. A to I. That's what it needs. It needs a const cast. How to convert this into const? I think there's some fucking concept or some shit in C++ where I can tell it to ignore the const. Maybe I should use that here. No, how can this be const if I have to edit it? I think const doesn't matter. You can just pass a cast and it'll assume that it's const inside the function. That's fine. What else can we do? This returns what? An integer. What does it return? Does not affect the error. No, it's part of stdlib. Okay. It returns an int, right? So it returns patent. This should be fine. Because we need to return in star. Okay, this should be fine. Because they don't really care. If it's not a digit, then it probably doesn't satisfy our needs anyways. So we can just ditch that part. Okay, now we come to the hard. Hard, I say, but that's only because I'm dumb. It's probably very easy. But for me to wrap my head around it will be a nightmare. The array, sorry, the object. Should I do the array first because it can only pass an object? I think that should be the right order of things. Maybe I shouldn't be defining the functions before I write the definition. Sorry, I shouldn't be declaring the function before I write the definition because, like, we notice the arena T part and we make some random changes. Yeah, and I can just copy paste the shit at the end. So from next time, we will be just writing out the functions and copy pasting the definitions at the end. Okay, let's do this. An array is square brackets, so we gotta do the if JSON string not equal to sorry not equal to square bracket open square bracket, right? The JSON string is not equal to open square bracket. Oh, sorry, invalid. Invalid parsing expected return null. null footer. We just keep returning null footers. Fun. And, and so I don't know. It looks nicer to write null footer. The caps null just looks ugly, but all good. Let's just keep it as null for consistency. Right. Now we are in the array. The next character, yeah, so we consume, then what do we do after this? We have to check another check. Instead of this, it should be this, right? And once we do that, we can confirm. Now we know for sure that it's an object. Now we call parse object, right? It gets us the object, and the parse object will handle our consumption of the parse object will handle the consumption of the curly braces, right? And we pass the object. It will return the object, object key, right? It returns the object D pointer. And once we get the object D pointer, we have to store this inside the array. So I think we declare uh, the array T here, array T star red. Okay. Uh, what we do here is that array, or like, what do I call it? The- Is it Control E? What is this ship called? Why did I create this value T, by the way? Oh, right. It's for the struct KV. Right. Come on. Object T. Objects. Okay. Oh, let me just add this. Is it? Oh, I forgot. I'll have to remember the shortcut for that again. Okay. Anyways, we're at ret array object. We call this object. It should really be objects, right? It's objects. Objects. We get an objective pointer. Would we just store the objective pointer? Objects plus plus that array count plus plus. Before this, we have to find some assign some space for the shit. Why am I calling it an array? What am I doing? I'm kind of like lost. Oh, it was right. We have to assign some space for this. So arena lock arena pass the arena pass the arena here and size. What's the size that we want? Hmm. What is the size that we want actually? We had to allocate the size every time that we get the object, right? Because we don't know. Oh, okay. Size of object. Do we need a new array T or do we need a new? This is kind of confusing me right now. How much size do we need? We need size of. We just need a size of array T, right? Because we don't need the object T size would already be allocated in the object parsing function. And we need like an arena. I just realized that we would need like an arena freeing thing. So let's just start with this for now. Array T. I think I'm going too far ahead. We get the space for our arena, right? And then we assign the object to the arena. How much space will it allocate when I say this? Since it has like star to star. Just confusing the fuck out of me. It'll just allocate like one memory space. Let me just look this up. Okay, so it allocates a pointer space. So this will take 8 bytes, right? Mhm. Now, do we want to allocate 8 bytes or do we want to allocate? Yeah, okay, that makes sense. So what we're doing right now is we allocate enough space for an array T and then we pass the pointer to that amount of space. So this has enough space for one array T, right? And on array T has an object T pointer or double pointer, right? And hmm, when we do this, we access the double pointer. Plus plus is an allocation to new double pointer. So should it be like doubly dereferenced or what? So pointer is like storing multiple pointers. Why would we want multiple pointers? Because each pointer points to one element. So ret object is object type pointer, which is stored inside this pointer. So this is pointer, and we're equating it to pointer. I will have to dereference this, right? Or what? What would it be? Mm. Mhm. Mhm. Yep, I have to dereference this. Now, I'm thinking I need a capacity for this RAT. Because if it exceeds the capacity, so the number of pointers that we store would be exceeded. This is so fucking confusing. I should have just fucking used a vector or something. Hmm, this is hard. What would it be? Capacity. Even if you have a pointer, we want to know how much memory space that is allocated, right? We are thinking about how many objective pointers we'll store. Am I going a level deeper? It should be in terms of array T. It points to some memory space that's defined. Let's say array T, it will have enough space, so it'll have like 8 bytes plus the 4 bytes for the integer count. So it'll have 12 bytes, if I just say this right now. But what we actually want is what? What do we actually want? We just need one pointer, or do we need multiple pointers for object T? Do we have to like do the capacity thing is what I'm thinking about. So let's say we have one pointer, right? So object T is one pointer. It will be a object T pointer that is stored in array T. There should be multiple object T pointers. It should store multiple object T pointers. We don't know what that is so that's why we use a pointer instead of a pointer of arrays. Right. Okay. So we definitely need a capacity, and we will need to add that to the this thing, right? And if the capacity is increased, you'll have to arena alloc some more space. And the arena will do the actual memory shift that it needs to do to get us that space. I just need space for one array T, but I also need space for the object. I need to arena alloc space for the objects. So in the loop, I can do the plus plus thing. Okay, let's start with that. I think I'm on the right track. It's just a little bit more. Include. Let's add IST. It has a capacity, right? Now this capacity is what? Okay, we get it. Capacity. Battery. Battery count. Then uh, battery checks equal check. Oh, let's just allocate double the current capacity. I mean, we probably waste a shit ton of space. Battery the capacity tells us the number of object T stars that we'll have, right? Uh, 50, right? Because we're doubling it. Yeah, so before this, we do battery. um, Yes. We can delete this from here. Else, this should happen regardless, right? Okay. Number four, out of this, we will have to initialize some capacity.